Hello everybody, how you all doing? Hope you're having a wonderful day. We're going to do some programming today. Why? Because I wanna. Uh, I don't know how many of you remember my old project, Project Stormwind. Uh, it was something I was really excited about. I was working on making basically a WoW model viewer, but specifically aimed at exporting the file formats. Then the whole thing with Blitzchung happened in 2020, and Blizzard just kind of went severely downhill from there, and I just basically full stopped everything that had to do with World of Warcraft or Blizzard or anything. I don't even play them in my off time because I don't want to give them the fucking satisfaction. And I think that's gonna stay in place until I see how things happen at after this merger slash acquisition with, I think, Microsoft. But that's not the point of today's stream. The point of today's stream is this. This is Project Midgar. Now, some of you might, see it and say, hey, isn't that? And yes, it is. This is the first iteration of Project Stormwind, or rather the latest iteration of Project Stormwind. Now, I stripped all the WoW stuff I could from it, and now I am building it up as a Final Fantasy VII model viewer. So it's going to basically do the same things, but for Final Fantasy VII. As you can see, we have a fully functional, little, viewport. Although it doesn't, rotate around where you're looking, it rotates around, the item itself. I'm going to have to fix that. But this should do what we want it to do. The thing we have to do now is get it to read the files. So I've been doing some work, and if I come here and open files, and let me get up to go away. I don't know why that pops up every single time I open up a file browser. Oh, probably under fan projects, yeah. Final Fantasy VII, and let's go to original files, which is where I'm starting it. And I haven't done battle files because that's going to be a headache and a half because there's no file extensions. I mean, look at it. It's A, B, C. There's no file extension, so there's no clue of what it is. But if we go to the field models, they do have file extensions. So I know that that's an animation file. And then there's text files and RDS files and HRC files and P files. So let me quickly explain what each of these are. You have the HRC files. These are going to be your hierarchy files. They basically say, hey, this, use this and this, and this file. And this goes at this distance, at that distance. So, it's a pretty straightforward file. You have your RSD or resource files. And they basically say, okay, this is all the images that you're going to use. This is the hierarchy files. And lots of it. I mean, here, look, PLA, poly, AC. So that's the polygon model, that's the material file, and that's the group file. You notice they're all the same thing. And then there's 0 textures on this one. Well, all of this is merged into the P file on, Windows, which is the very next one. So this contains all of our geometry. So at the end of the night, my hope is I can grab pretty much any P file, hit open, and this will update to be able to view that model piece. If we get even farther than that, I would love to be able to do hierarchies and get that up and running. I don't think I ever got bones or a bone system running in Project Stormwind, so that will have to be new territory to explore. But today's goal is to get it to actually open up the P file and display the models inside accurately. So one thing I want to look at is the RSD file. Now you notice I selected it It says current file is the RSD file, but nothing happened. That's because it just read it into memory. It didn't do anything else. If we look into my log file, we come down to the bottom. Here, RSD read date is Saturday, January 2nd, 1994. Using the PLA, the mat, and the group, and no texture files. So, that's a nice little bit. But we can, also come in here and say, hey, let's look at the hierarchy file. Now, you'll notice nothing happened. Nothing changed. The current file still says the RSD. That's because I haven't taught it to read HRC files. You can see here, attempting to open the HRC file, checking if resource, checking if polygon, and that's it. That's all I've had it do. If I tell it to open a polygon file, you notice it doesn't even say, current file is a polygon file. Let's open up the text file. And it's saying that this is not a polygon file. Why? That's one of the things we're going to figure out tonight. All right, so file is not a polygon file. Let me just close up some of these things. I was trying to do some fixes and stuff, but doesn't always work. All right. So last I checked, I was working on trying to actually get it to freaking open. Okay. Now there's still some wow stuff in here, like you can see these lines in here. Actually, let me make this a little bit bigger so you see ADT equals null and all that, and that's basically trying to clear out all the old stuff. So anything you see commented is more than likely old code that we will have to replace at some point. Except maybe this. All right, so we had a function in here of loading Final Fantasy VII files. Here we are. Now, the reason I'm actually having it specify Final Fantasy VII files as opposed to just open a file is because I actually do intend to get it to do remake files. So I'm going to have to eventually teach it, some Unreal Engine file formats, which means I have to actually find and understand the Unreal file engine formats. That's a headache and a half. Okay, so here we go. Polygon is polygon file equals no valid data. And it's saying file is not a polygon file. So let's see. Attempting to open. Attempting to open a file with extension P. Checking if resource file. So it's trying to do this. So let's go here. Okay, it's going to do that one, which checking if polygon file, if file exists, unable to open. Okay, so it's one of these is getting hit. So I guess the question is which one and why? Am I reading this in the right data format? Let me actually, I can actually open up this. No, let me close that. All right, I'm gonna open the file. I actually have this on another window, so please excuse me. Do 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 do. All right, there's the folder. Okay, so here is the file. Am I reading it in the right bytes? Am I reading it in Big Indian or Little Indian? Huh. Well, let me Let me see. There should be like an option here somewhere. Hex, ANSI, lit, overwrite, right. Oh. Bum, 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 bum. There's just some good music here. All right, I have no recollection. Ah, wait, Indian. There we are. Little Indian. All right, and Big Indian would be maxed out. So we got to make sure that we're on Little Indian. Indian. I don't know which it is. All right, so Q file set Indian. Oh, not in here. All right. File and okay. So what about raw data? Okay. So how do I swap Indianness? Well, okay, let's try this. Yeah, we got the read, so let's actually peek that. Oh! That would be why it's not doing anything. I forgot to do that part. Okay, so for this, I'm going to open a new folder. And I'm actually going to reference my old project. Because Project Stormwind still has a lot of good information in it. Alright, so... Okay. So start with log file info. Let them know that we're reading the header. Gosh darn it. All right. I need something a little bit more complex. Nope. Not gonna happen. All right. All right, so let's just do this easy. I need to know. All right, so we have the start. So you know, I actually need to open up this file because there we go. All right, let's just actually, can I yes. So this equals reinterpret cast p header data mid start len. Cast type to p header is not allowed, huh? What about that? Invalid conversion. No? Okay. Alright, so let's do p header. Well, let's call it ph. There we go. Okay, so could I do this? All right, now let's do p header ph this equals ph. Let's see if this works. Probably not. If it does, that makes things a lot easier. All right, recent p. Hey, it didn't. Maybe. File is not a... Okay, reading p header. File is not a polygon file. All right. So let's just assume for the moment that while this will correctly grab the data, it can't convert it over into what we need. So let's just grab that. Version equals ph dot. No. Cancel. Version. There we go. dun 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 dun. Alright, so this for int I equals 0, I is less than 16, I plus plus, there we go. Bum 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 Sephiroth. Really? What problem? Oh, okay. Not that it really matters much. All right. Okay, it's still saying it's not a header file. Log file, debug. Header data version offs vert type. All right, let's see what this says. Oop, closed. Oh. Yeah. Okay, so open. And what does the log say? The log says negatives. If I put it to U, will it work? I think U is probably unsigned. Either way, I think it's wrong. So, Okay, well, let's try this. Okay, so from what I could read, it sounded like I could just use standard reverse, and it would reverse all the bytes, and that might fix the Indianness. So let's see if that fixed it. And I just got invited to Jump Town with some fun. They're about to turn off the comms. That is very tempting. Okay. So... oh, was it because I was using U instead of... So if I disabled that now... Alright, what do you have to say? Okay, so that the reverse thing did nothing, but it's absolutely reading the wrong data. So, I don't know. Maybe I should instead of just, doing something shitty like this, I should actually, go through it and read all the data. Let's give that a quick shot. So, first data is version. So, version equals data mid to uint. I believe it's a uint. Yep. Okay, and then this will be start plus 4, start plus 8, start plus 12. And that should be good enough to... that should be a good enough start. And we'll just see how that works out. So, build. Oop, close. I keep forgetting to close it. So this should give me the 3 things I need to double check that it actually is what I want it to be. If I can get it to at least acknowledge it's a, a P file, that would be an achievement. Or at least an improvement. Ooh. Well, it's reading the data, but now it's 0. That's not right, because I can clearly see that it's not. Okay, start should be 0. Now, here's the thing. I don't need that, actually. Now that I think about it. The header is always going to be at the beginning. So 0, 4, 8, 12. There we go. Do, 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 do. These are all uints, so. Oh, wait. Oh, okay. Do, 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 do. Do, 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 do. Do, do, do. Do, 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 do. All right, and log file says still zeros. All right, didn't really anticipate a change there, but would have been nice. Okay, so do, 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 do. Constant begin. All right, data end. How did I do this before? Oh, you know what? Let's take a quick look at how I read things here. Get Q band number. Okay, so apparently I had some, things in here. Yeah, we got the flip C, flip CC, flip BA, get Q band number. So, yeah. We basically flip everything. All right, well, let's give this a shot then. Get Q band number int. Nope. All right. Oh, you know what? This actually needs the foundation functions in it. So, there we go. Now the good news is I can just go whomp, whomp, whomp. Okay, so now it might work? Question mark? I'm glad I left a lot of these functions in here. Nope. Still getting header data of 000. Am I even opening the right file? AAC, yeah. Okay. And, yeah, that's what I have here. I should be seeing ones. I got so many files open here. There we go. So even if I flip the Indianness... Oh, Control E does that. We should have been getting 16,000. But we weren't. So we're basically not getting any data. Okay, so let's come back in here. So we're checking is Polygon file. All right, go to that. So first thing we do is we have the file name. So well, no, we know we have the file name or not. So now it's returning is Polygon file, checking if so we have. Well, actually, no. Do we know? Yeah, I don't know if we know at this point. So let's double check. Debug. Checking. Oh, it's a dot, not a dash. Okay. Checking %s. Checking if %s is a polygon file. And let's see, backslash question, backslash quote, and then enter q printable. File name. All right, so now it's going to tell me if I can get at least the file name at this point. If file can read line, read, ready to read, ready read, wait for ready read, set current read channel, can read line. I guess that's a good thing. All right. Actually, we don't even need an if there. Can read line. And we're going to tell this to print out if we can read the line. Okay, and after we've gathered this, and we've closed the file, or do we need to actually keep the raw data the file open while we're still working with the raw data? I don't know. I doubt it. But let's see a couple of things. First of all, we're going to make a new log file here. We'll just reuse this old data. Raw data size. Raw data size. File closed raw data size. So we'll see if there's a difference here at all. All right. Invalid polygon data. Cannot open file. Holy crap. So somewhere along the way it got fixed? Alright. It read the P header. Checking file size. Close file size. Okay, so they were both fine. Can read line false. Yeah, that's fine. Alright, so let's do some more. Normals. Unknown 1. Text C's. Vertex colors. Num edges. Alright, 20. 24. 28. 32, 36. That should get us to num polys. And there's still more we can grab. Let's just finish it off. I think the groups might come in handy. Bounty boxes, not so much. Alright, 36, 40, 44, 48, 52, 56, 60. So now we're at 64. So the next are up. So let's take this, paste, and we can okay, so you can't recognize that. Gotcha. Okay, it goes 64. Actually, int offs equals 64 plus I times 4. So the offset will be 64 plus I times 4. We can get rid of all that code. So yeah, just a little bit of hard coding, I guess. Yeah, we'll get used to it. Okay. Hey! It read the file. Okay. Polygon, the header, yep. So it checks again. All right. It is a Polygon file. Perfect. So at this point, we are getting to right here. It's, opening the file, it reads it, then it adds it to the last thing. The next thing we have to do is actually have it read the data. Now, we actually have it set up so that when you open it, it reads the file, especially if you give it a file name. So now that we're here, we can actually read our data. All right, so p header, or let's go header p file. What did I name it? It's been a while since I've came back in here. All right, p file. All right, p file. Header, or read. Go to definition. So first thing it does is it reads the header. Perfect. So next thing it does, and actually we can, basically declare, this function done. Or rather, this function done. We might even want to do a file open. Well, we are at this point. We already know it's openable. We already know it's a a Polygon file. Okay, so I am being tempted by going to jump down. Okay, so the next thing we need to do is we know vertex type, we know the number of vertices. So let's so let's actually record our vertices. Now, vertices, as I understand it, is basically it's a vector 3. It's fairly simple. So from here on out, we need an offset. So I forget what I was using. F_pause location. No, we'll just call it pause. Maybe it's FS. File data, mid. All right, so uint 64. Okay, now I gotta know. I gotta know what the other was. Oh, let's close that. Fpause_t. Okay. So we're going to use this to keep track of where we are. So we already know that our offset here is whatever that is. It's basically 128. So So that's the size of that, so we need +4. Well, no, that's the starting point. So, at least I think that's true. A few more tests. So, from here, we do actually have to keep track of this because this data is no longer static, because number of vertices makes a difference, number of everything else. So let's start with vertices. So for int I equals 0, I equals less than header num verts I plus plus. What? What are you complaining? Okay, fine. Better? Good. Pause plus equals 4. Okay, so well, actually, we could do this in subgroups, couldn't we? We could, but I'd have to create a new, grouping for basically everything, and I don't necessarily have to do that. So actually, we're going to be plus 12 because we're going to do this 3 times. So here we're going to get vector 3f a, and here we'll get file data. Okay, so what's the problem? Expression must have a class type, but it has type. What? Oh. Vertices, push back, A. Now, we could just do, the math. It would be easy, but we could also just, put this at plus. But we want to keep track of it for the whole file. And while this won't be the easiest way to do it, it will be a way to do it. So using this, we should get the positions for all the vertices. Yay. We can also skip ahead and do a lot of other stuff, but I think just grabbing all the data, at once is probably basically just the easiest thing to do. All right, so next up, normals. That's just another vector 3. All right. Num normals. Normals, push back. All right. What's next? Unknown 1. Next, UVs. Ooh, okay, so we're up to a vector 2. So we'll basically do the same thing. Num UV, or texture coordinates. Why is it listed as that? Should be UV coordinates. Well, it's because I probably copied other people's stuff. Num UV coords. There we go. I have to make a few changes here. There we go. Now this is just a vector 2 float, so and we can take this down to A. UV coordinates, push back A. And we gotta switch that to Y. Oh, I'm just noticing that the coordinates here are backwards. I don't know if we need to swap these or not, but I'm going to, just because I don't know. Alright, what's next? RGBA, or 8-bit, huh? Okay. So that is... it won't be too bad. For the vertex colors. Vertex colors. RGBA color. I do actually have some old, things I can do for this. So, B. We'll get int, and this only has to be a size 1. Oh. 2 and 3. Push back 4. RG. And then A. And now this is vertex colors. Yeah, that's right. I was thinking, is that 4? Yeah, that's 4. Alright, next up, poly colors. Literally the same thing, just poly instead of vertex. Num poly. That's not right. Where did poly colors come from? I have no idea where that came from. All right, edges are simply an integer. So, num edges. So for this one, it's actually fairly simple. Int A equals that. Edges. Now I have no idea what that's actually going to do, but we'll find out if we ever get to there. We'll read it anyways. Either that or we can just skip it. Alright, now we're up to polygons. So, actually I'm going to copy that. Num polys. P poly. P poly. All right. Normal index, vertex index. Oh, we got a lot of data in here. So the p-poly, let's just double check. All right, so we got a short of 0. So this is basically always 0. And it looks like it's all unsigned shorts. Which is 1 bit of data, I believe. Is it? Oh shit, am I reading enough data into these? No, unsigned shorts are 2. That's right. Polygons, push back. Next up, vert index, and there's 3 of them. Vert index 0. 1 and 2. Normal index. Now I could probably do this a little bit better. Actually, I could probably do this a lot better. One, 2, plus 10, plus 12. Okay, next item, edge index. $16, $18. This is a lot of data. Finally, the UVs, and there's only 2 of them. Oop. What happened there? Copy, paste, UV index, plus 20, plus 22. That gives us a total of 24 bits of data. No, that's an integer. That needs to be 4. All right. I think I have this right. The good news is I can, come back and fix this if it's I don't. All right, so that's the polys, and then we have unknown 2, which uses the same format. Oh shit, you know what I've realized? I forgot to do some stuff in here. So, pause plus I. Because if we're not using position, then, that doesn't help this at all. I dare say it could cause catastrophic issues. on the edge of despair. Alright, so now that I have that, copy, paste, and save. Alright, so this was unknown 2? Yes, unknown 2. Okay, so now we gotta look at P100s, and we could probably just skip the rest. Because really we're only going to need the polygons, the vert coordinates, the UVs, all that good stuff. So we'll come back to this in a bit. Let's see if it compiles. Always good to check if it compiles. Alright, we're getting some signage issues. Yeah. Not that I ever really care about that. Alright. Compiled. Open the RSD, that's fine. Open the P file. That worked. Alright. Okay, so the data is getting recorded, but we don't know if it's actually in there. I mean, we can guess. But, what the easiest thing might be? If we just come here and build the model object. So this is turning this data into a model supported by, our mesh. So, I actually need to use a break for the bathroom. So, we'll be back. Okay, let's get back to this. So, how do I build the model object? It's been quite a long time. It's been like 2 years since I've touched this program. So I don't quite remember how to do stuff. So I'm going to actually jump back into Project Stormwind. Ow, my finger's hurting now. Let's see if I can get this to give me the info I need. Okay, that's finding that. That's doing that. Build object model. Okay, so here we are. So, what we want to do is build the model object. All right, let's start with the log file. Info. Building. Field. P. Or no, just field. Just P file. P file model object. Okay, so if model scene, now we can just copy some of this stuff. So now we have a new model scene. So model scene name equals what's our file name? You know, I'm not sure we kept our file name. Yeah, we did not. So let's do that. So we're going to tell it whenever it does a read file. And after we've confirmed that it is actually, you know, an openable file, we'll set the file name to file name. That means down here we can set this to the. We need to basically figure out. Actually, that's not a bad idea. We'll just copy this and change this to file name. Although I should probably change this out to like a directory separator. So qdir. Actually, do I have qdir in here? I do not. Qdir separator. Just a little bit better than my last program. So now we have a model scene name. Our model object is going to be a new mesh. Our mesh data collision. I don't think we need to worry about that. Yeah, that's not something I need to worry about. All right. So, model object name, object name equals all that. We'll just do it fresh. I mean, it's better than just saying it's the scene name, because that might cause connection issues. But we're also going to append it with mesh. So now, and then at the very end, I don't have an object built modifier. That's not that should be in here. Oh, okay, that was something I added. So I don't need that. Although it's not a bad idea. Okay, so let's start with the vertices, shall we? All right, so and P file vertices. Okay, and I can't remember if I can actually, if I have a setting for seeing the vertices. Maybe I should have one. No, you might be able to see them in polygon mode or wireframe mode. If not, we should probably add that. All right, model point A position equals P vertices at I. A normal vector equals P normals at I, because these should all be the same. And let's see, UV data. UV position equals UV coordinates. And now model. Wait, am I doing model? Okay, yeah, I messed that one up. So we'll come up here. Original file name equals file name and let's see, model point list push back A, model bounding box update min and max A dot position. Is that right? That looks right. Oh, I probably need to do just that. There we go. Okay, so that should, at least in theory, set up our thing. So, what do I do with model at the end of this? Ah. I mean, we could just calculate our own bounding box, or we could just copy from the others, but I feel confident in taking from them. Alright, let's see how this does. Okay. P get read result. Is polygon file, P new file. If read result equals no error, set the current file. But there's also other things we're going to have to do here, isn't there? Isn't there? Yes, sir. And why don't you lay them out for us? All right, sir. First, we need to kill a pig. What? Oh, yes, sire. We need to kill a pig. Okay. Dun, 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 dun. Boom, boom, boom. Dun. Okay, so all right, so load P file into Vulkan. Okay. Whew. Hopefully this works. I doubt it, but... Well, no, I don't doubt that it will work. I doubt that we'll see anything. Why do I look so dark? Oh, I forgot to set my camera up again. Yep. I keep trying to get this to set it to the right numbers, and it keeps wanting to reset. Does that look better? You know, I think I'm going to go with that. I kind of like it. A little brighter for the room. Alright. Okay. Everything compiled. Fingers crossed. And we index out of failure. Okay, out of range. All right. Can I try to debug? Nope, just crashes. Loading, building P as model file. That's the last thing we heard. Well, yeah, that's not surprising. I mean, that's the last thing we did. Assigning vertices. Let's see. Vertices. Okay, I'm looking at the way they have stuff and the way we have stuff, so I think we're going to have to do this a little differently. So actually, we're going to go for the P files polygons. And we'll go for the, what class is this? P-poly. P-poly. Poly. Equals at I. So, one second. Let me take another look at things. So this is going to tell me where the vert indexes are for each of them. So basically, everything's going to be its own independent vertices. And I'll have to go through and do a cleanup afterwards. That's probably the best thing to do. I don't like doing that. Okay, but that's probably going to be the fastest way to get things going. So we're going to have our model point. Actually, no. What was the other setup? So there's polygon data. There we go. I mean, I can take a reference from those, but this is really what it is. So it's going to give me an index. So let's start with the vertices then. Because I'm going to need these model points, and then I can work on the polygons. No, I kind of need to do both at the same time, don't I? Alright, so model polygon. I'll do that as B. So for let's just make this easiest on me. For int v equals 0, v is less than 3, and v plus plus. Wait a second. Okay, they have their data listed independently, and then they go through and list positions and stuff. So what I would have to do is create 3 model points. Okay, so it looks like the way this works is that it goes through and tries to identify, it says, hey, my vertices are these. So we can actually, in here, create the model point, and we can say poly dot vert index at 0, or at I, or v rather. Well, actually we'll do parentheses v, and that will give us the index into the vert count. So yeah, what we want to do. Alright, so creating vertices. Now, unfortunately, the way they do things and the way I want to do things are very different, so I'm going to have to make some changes to one thing or the other. So it's giving me the index. So, well, let's start simply. We'll clone this. P-file vertices. Bring that up here. All right, so we have the model point, a position equals, well, actually, first things first. Nah, just that. At I. Unfortunately, that's all we can do. I want to be able to put the UV positions in there, but I don't think those will match up. Will they? We could try. Alright, model point list. And bounding box update. Now there's still the normal vector to deal with. So actually I do not want that. So the way I do this one, P, you know, uint32 P0 equals polyvert. Polyvert index 0. 1 and then 2, 1 and then 2. Just make this super fucking simple. Actually, I want this to be poly. Nah, we'll let that be poly. Poly! Actually, okay, yeah, that we'll do this. We'll just go with that. Well, that'll be the first step. Okay. So we know the vert indexes, which should be their index in here. We can then use that data to expand the rest of the data from in here. So, no. Unless, yes. Normal list. And let's see, what was the other data? UV. I don't need edge. I don't see a need for that. So this will be 2V, so UV list. So having done this, and we've now have our global ones, we're going to build up these lists. So, in fact, I can just do that just to make it clear. UV chords and normals. Now I don't need any of that. So for this, it's gonna be pretty simple. Well, actually, Why am I doing that? I already have them here. All right, so model pointless. Okay, so creating vertices. Creating polygons. Actually, these should be debug. Yeah, that one needs to be info. These need to be debug. Populating vert data. Yeah, okay, that works. Assembling polygons. Okay, so the point list is actually pretty handy here because we can go P0. So now we have access to that point. Well, here's the nice thing. We now know the UV and normal vectors for this. So the normal vector for this is going to be equal to the P file. Do I have, yeah, I do have to have caps on. Normals at polygon normal index 0. Why are you having a problem there? Constant. All right. Fine. Yeah, happy? Ah! Okay, so the Vec3D copy paste. Oh wait. Vect3F. Preceding parentheses cannot be called. What? Ah, okay. Alright, so now you're not going to have a problem? Okay. What if I do that? Fuck that. Yeah, that's fine. But fine. You're gonna be like this? Let's be like this. Now what? Expression must be modifiable. You piece of... Okay. Value. Nope. Okay, fine. Now will you work? Thank you. Alright. P1 and P2. So there's the normals. Let's get the UVs in here. Now this is only going to be 2. UV index. UV index. UV position. UV position. And then UV coords. Okay, what other data do I have in here? Edge. Edge rewards. Is this right? Would there be 2 of those? Yes, there would be. Okay. But that would have 2 of them available. So 1, 0, and 1. But I feel like there needs to be a 3rd one here. But I don't think there is. But then won't I need a UV position for the 3rd point? Ah. I'm pretty certain that, you know, these are accurate. One, two, three. So yeah, that's getting the normals. Yes. These are getting the UVs. Of which there are 2. That doesn't seem right. Well, this is going to be fucked up, so let's just, deal with it later. Let me actually look in here. Point UV data count is great. Screw it. At any rate, we've got that. Wait a second. That can't be right. Why does it have a UV index of 2 when everything else has 3 points? Wouldn't the UV index need, 3 points as well? I gotta look at this up. I actually put this somewhere. Where did I put it? Of course, it's missing. All right. Yeah, I just feel like there's something wrong here. Okay. Texture coordinates. An array of vertex. This section is 8 times number of coordinates. Texture coordinates are able to be read through group info. Through group info? Groups. Oh, shit. Did I ever deal with groups? Yeah, I got groups. Primitive type. Polygon start index. Oh, shit. Texture coordinate index start. Are textures used? Texture numbers. Oh, I think this is probably going to fail on us unless we do that. But let's let that go for right now. So B 0.1 equals P0, 1 and 2. 1 and 2. And we'll also have to set the material for this. So material ID equals 0. Because apparently I haven't set that. So, don't know if this is going to work or how it's going to work or if we're going to get another crash. recent files. Assert. Yep. What does the log say? Populating vert data. How do you crash there from out of range? We are literally going through the vertices count. And actually I can set that up to int. P file vertices at 0i, a position, and then pointless push back, and then that just updates the bounding box. Did literally nothing. Let's see if it does anything different. Oh, I see. No. We were populating the vert data. Because we're probably not going to use these anytime soon. Let's just bypass that. We could definitely, enjoy that, but... Let's see if we can at least get the model to show up. Wrong mesh or material count unable to load. Well, I guess I gotta, Oh, yeah. It assembled the mesh. I'm actually going to turn these off right now. Alright, so we're having the error where wrong mesh or material count. So, where do I actually add materials? Okay, so I can actually do this next before building the model. So, name equals default. We'll get more fancy later. Okay. I mean, we could also do stuff like color texture has specular, yeah. Alpha is specular. Yeah, we got to also include stuff for, vert colors, so we'll have to improve the system for that. But let's just get this up and running for right now. Because I have no idea what model this is. I mean, I could probably look it up. with other programs that do read this. Okay, Vulcan device 405, huh? How did it... I haven't done anything, have I? Compare with unmodified. Oh, okay. You know, I don't think it's ever been taught to not need textures. So maybe that's what the problem is. Well, actually, no. It was taught. I mean, you know, I can, you know, see the textures right there. Out of device memory. How am I out of device memory? My device has shit tons of memory. This is the problem with basically, you know, making your own Vulcan, you know, setup. Res equals VK. Okay, so VK allocate memory. It's going from the buffer. Buffer devices, the logical device. Yep. Okay, I think I gotta look this up. VK result. Error out of device memory. What do we have? Okay, out of memory when loading assets from the scene. I am loading lots of assets, but thought the simulator was meant for blah, 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 blah. Okay, this is something different. Out of device memory. Device memory allocation has failed. It's not saying it's out, it's just saying it didn't actually process and connect for some reason. Well, you know, it has been like 2 years. Maybe I should, you know, check my code references. But, you know, the other thing I could do is probably come in here. Well, no, not in Foundation. I'll go here into the engine, I believe, or the window. Set scene data. Here we are. New scene is null. Okay, so we're not getting any of these errors. Let me load up the log file. Creating polygon. Okay, building Vulkan model data. Set scene start time. Set scene start time. Yep. Prepare start. Vulkan load. Vulkan load all materials. So, set scene start time. Prepare. Go to definition. Prepare start. Build command buffers. And we're preparing the pipelines. We're building our command buffers. Post draw time. Not getting post vertex descriptions. Getting that. All right. Okay, so okay. So this is where it was actually, running out earlier. But we seem to have passed that. I'm going to re-enable this. Expression must have a class. Oh, you know what? We don't have textures. Maybe that's the problem? So it's trying to do textures? Telling the device to wait, release the resources. Load scene. Vulkan data. Okay. Where's my back button? I used to have backwards and forwards buttons, but I'm not seeing them now. Alright, back to the window. Set up vertex descriptions. Prepare our pipelines. I'm pretty certain all that's fine. Update uniform buffers. View change. Prepare. Prepare start. Yep. Post vertex descriptions. Okay, we're not getting down here. Post vertex descriptions. There we are. Okay. So, scene. If scene equals null. And we generate the square. Vulkan engine, create command buffer. Yes. Scene load. Let's peek that real quick. Vulkan start load. Yep, there we are. Load all materials. Number of share materials, number of models. Load all materials and load all materials in time and seconds. Load all materials. Okay, so we're getting here. And then it's going load meshes. Go to definition. We're going to need some of this information. Boom, boom. Vertex buffer, staging buffer, target, index buffer, target, copy buffer. Yeah, I built this so customized that I feel like it's not giving me enough stuff. So, support that. We've got much, a little bit more details here. We'll find out exactly what's going on. Yeah, I built this so in tune with how World of Warcraft does stuff. I never anticipated doing it with another program or another thing. So, all right, that's what I anticipated. But mesh unknown model. Material default num faces 0. Start count 0. Index 0. Okay. Mesh equals model mesh data. Model data at 0, mesh data. Oh. Am I just doing this all wrong? Vulcan seed data. No, that's all right. Alright, source data. This is all looking correct, as far as I can tell. So it does the first index, and then I think it gets to here, and then crashes. Or it does all this, and then crashes. Actually, it shouldn't even do this, because it would start at 0, and see, are we, is this less than this, and then fail. So it would just go straight to that, plus that, which would still be index base of 0. And then meshes gets pushed back, and then it just keeps going. So now, log file, debug. Vulkan. Creating buffers. Loading Vulkan meshes. Creating mesh buffers. That's what it'll be. So we'll have this, and we'll see if we can even get past, you know, that. And that will let us know that all this is working. In which case I can probably just do this, but... All right. Yeah, we're just trying to investigate. Okay, it's creating the mesh buffers. So we don't have to worry about anything up here. So let's just... Although it's kind of disappointing that that's an unknown model. Okay, so we're creating the mesh buffers. Building submit info. Destroying staging. All right, copying data. So we'll see if this, you know, if anything in here is not reached. First step, find out where it's crashing. And then we can start commenting things out and see if we can get it working again. All right, creating mesh buffers. Okay, so somewhere in here, in between there and Vulkan copying data, is where we're having the problem. All right, vertex buffers. Okay. Vertex staging buffer. Vertex target buffer. Index. Copy, paste, staging buffer. Okay, so this should get us a little bit closer. But it definitely looks like I'm seeing memory usage here, so... Let's see if we can even get here. Although I have no problem believing that these work. And it could be that we're doing something wrong. All right. Index staging buffer. So It's right here. This is the problem. Indices data. There is no indices data. All right, so loading meshes. So because there's no indices data, for some reason, that doesn't make sense. We should have indices. All right, let's open up the window. So we're going from, okay, it's trying to load from there. Get scene data. Or set scene data. Are we actually... Are we... Where does that happen? Somewhere... Okay, so close that, come back here, classes, modeling object, model points, model polygon, model bone, material, model mesh data. Oh, you know what? Here we are. It's going to be in here. Build Vulkan data. Yeah. When you set the model object, it builds the Vulkan data. So we are setting that data, correct? Set scene data. P get Vulkan data. All right, let's do this. If scene equals null pointer, build Vulkan data, return scene. All right. So build Vulkan data. All right. If not that, build model object. Yeah. Okay. If model scene equals that, okay, then we, yeah. All right. Good. Building Vulkan model data. Let's check the log. Building Vulkan model data. Holy, why is the bounding box so crazily big? I mean, I'm just now noticing, I was noticing these numbers earlier, but I didn't realize this was the bounding box. That's the second fucking center point? No. Point count is 14. So model 0, 14 pounds, no polys. What the hell? Did I forget to do that? I did forget to do that. Model object. Model polygon list. Push back B. So we went looking through all of that just because I missed one thing. Yes. All right, good. Oh, it worked. It actually loaded up. I mean, the values are still fucked up, but it might actually be working. So, let's see. Let's come... Oh, shit. I just realized. Okay, we're still doing that. So more than likely, somewhere I am doing something wrong. And that's why both the center point and the bounding box is messed up. So vertices are integers. So those are size 4s. Well, okay, let's see. Let's start with the vertices. So we know the vertex type is 1. So number of vertices. So each one should be that. So do I need to offset this? 64 plus 4 times 16. Which sounds like 64 to me. Yeah. So that is starting there, and it should be ending at 128. All right, so if we know 128 is where it starts, let's see if we can get an actual number. So position, that's the header. So that's our first float. So yeah, 128 plus I, which would be 0. Maximum of 4. Yes. And this would be I plus... Oh, maybe... Do we need to multiply I? Yes. I times 12. Because it's got to be the offset of all of this. So these would actually be... Although there's... Yeah, those are the same. These would actually be times 8. So actually we can make this just a little bit easier on ourselves. Int offset equals position I plus that. What? Arithmetic overflow using operator on a 4-byte value. How about now? I have no idea what's causing this. But the nice part is I can just, you know, come in here and change the offset however I need. Which actually shrinks my code significantly. And I can keep modifying offset if I need to. Okay, 12 times 4 times 4 times 24. Sometimes I just forget some basics when I'm doing stuff like this. Alright. That should be everything. I just don't know why it's complaining. But we'll find out. Well, it's not complaining anymore. It succeeded. I guess it figured out during compile time that, hey, it loaded. It's wrong, but it loaded. Yeah, I have no idea what this is. But it loaded. That's the important part. Yes, that's a much more manageable bounding box. Okay, so now we have to figure out what's going on with the coordinates. It may be that we do have to read them in the different order. Let me real quick. I want to open up an old program that actually reads these files perfectly. And let's see if we can compare them. So this is bit turn. Let me grab field files. A. As you can see, they're going a bit nuts. So we are opening AAC, which would be this one. So it should be looking like this. And we are getting this. So let's turn off the backside culling and go wireframe. And we can see there are some things that look right, and then some things that do not. So if we were to come from the top, it looks like that. And almost looks like it might be able to do that. Alright, I'm going to push that off to the side. We're going to close this. We're going to come up here and see if we can fix this. So let's start with the obvious and go back to an XYZ coordinate. And we'll just start with the vertices and see what happens. Okay. Okay, so probably not. But hey, it's loading up. Okay, so let's see if I can find any information about positions. Vertices are red XYZ. That's all they say. It's XYZ. Alright, we'll just do XYZ. So maybe, let's see. Vertex index 1, 2, and then 3. Array of polygons. I only know the meaning of the specialized vertex indices. Vertex indices can be used or can't be used to directly select. You have to first read group information. There you will find information on which polygons and vertices you should use to form the model. Okay, so we actually do need to, grab the group information. So where are we at? Polygons, unknown. I think we're doing hundreds next. Okay, we just finished polys. So it's unknown 1 and unknown 2. Num unknown 2. Is that right? Yeah. Okay. Bum bum ba-dum bum bum bum. All right, and then num unknown 3. P unknown 3. A. Is a character, so. B and C plus minus 3. Unknown 3. Seriously? I don't have an unknown? I'm kind of surprised I don't have an unknown 3. Yeah, I do have an unknown 3. What the hell? Not giving it to me, bastards. Come on, you go bastards. All right. Actually, I don't think it will get me a... So we don't know what this is, so we'll just grab that. What's your problem? That's char. Oh, that's char question mark. There we go. So that, no. Slam. So there's that. I don't know why I'm grabbing these unknowns and everything. Okay, unsigned long, huh? Which is 4. Hundreds. Push back. A. How did I do this? Just 25. Okay. for uint, or no, just int 32, or int h equals 0, h is less than 25, h plus plus. A data h equals offset plus h times 4. So plus 100. All right. Now we are finally here, I believe. Let's actually come up here to something that I really like. We'll just go with that. Got so much to do. I mean, all right. So, yes, we are now at groups. Num groups. P group A. And I'll figure out the offset later. All right. A. Oh my, so much. Okay, let's come up here. That's all longs. Alrighty. Okay, and that's going to equal that. We'll put it to an unsigned long, which is what these are, correct? Yep. And that makes that a 4. Four times size of P group, actually. Why am I not doing that? I mean, that just makes so much more sense. Especially if things change. Alright, so let's just fix that. Alright, so 4F, 4F, 3F, 2F, rabbit, size of int, size of P poly, also size of P poly, because for some reason it uses the same data. We don't know why there's 2 of them. Unknown 3, hundreds, P group. There we go. And I'm out of drink. So thirsty. Paste, paste, paste. Paste, paste, paste. Paste, 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 paste. Paste, paste, and paste. There we go. All right, so for 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, 52. And now we want to groups, push back. And we can do this too. So this also is adjusted as we fly. And, one of the nice things is we're doing this in, a nice way that we can actually modify it after we copy it to other locations. It's always the first one that's the bitch. After that, things get easier. Okay, so bum, bum, ba, bum, bum, bum. Okay, so now that we have this, what other data do we need? We could grab the bounding box in the normal index table. Does the normal index table, what does it do? Not used anywhere. This section is 4 times vertices size. We're not going to bother with either of those, at least right now. So we have the data we need. Now let's go back to Polygons. And what we're actually going to do now is create a new... this is actually a little bit more in line with what I was doing, what I was referencing earlier. So let me close this. Dun, 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 dun. Okay. For int group num equals 0. Group num is less than p file groups group num plus plus. Count. There we go. All right. So now this is actually going to hold almost all of this. But we're going to move it in there slowly. All right. So first thing we need to do is figure out what our group is. So we need a p group. And we'll call this current group. Equals at group num. Yeah. I don't know if I should be doing this as references or not, but okay, so now we need that mesh data, right? Model mesh data. Yes. All right. So current group. Do you have anything good? Nope. You're all indexes. So we're just going to keep that the same. All right, so they don't even have group names, so. All right, so let's do this. Structure of groups. These indexes are group relative, and that means you have to add group index starts to the start of each vertex. Okay. Same is true with texture coordinates. Okay, so we could take the vertices outside of our except when we loaded it up, it didn't look like the vertices were correct. You know what? I think we need to actually add some functionality to view the view things, view vertices. Wonder how I can do that. Might just be a shader thing. Well, let me take a quick look. Vulkan shaders. Here we are. This would be a fragment shader. Well, no, we'll put it in, yeah, fragment shader. Okay. So wire colors. All right, let me take a quick look at this. Actually, you know, I haven't checked this in a while. Last commit was 2 days ago. Here, let's take a look together. Vertex attributes. Note on synchronization. Ooh. All right. Examples, I think it was. Vertex attributes. Shader interface. By the way, this is one of the tutorials that I use to build my shader, or my visual engine. First triangle, yep. Pipelines, descriptors, push, yes, yes, yes. Texture mapping, texture arrays, 3D textures. Ooh, he's updated. Subpasses, off-screen rendering, CPU particle sims. Beautiful. Nothing to drink, my lips are feeling dry. Don't need to worry about that just yet. No, it's not going to help me. Alright, so that's something I'm going to have to kind of dig into later. We won't deal with it now. It would be nice if I could see all the vertices, but I'm just not entirely certain how to do that right now. A lot more videos nowadays about this. Oh, what's this? Well, let's worry about that another time. So now that I have these, I can grab my vertices. Now, if I'm understanding this correctly, okay, so vertices. P vertices equals current group. Vertices start index plus I. So that will, push all that up. So, yay. So now we dump this in. And then we add this. But we come here. All right, num polygons. Okay, so, and now, let's see. Polygon start index. Goes P files at Polygon start index plus I from the current group. Alright, let me double check. Okay, we do that from the polygons, correct? Yes. Okay. Model object is updated. And the mesh list gets pushed back. And then we can add our material. And then we push back the object into the scene. Okay. This should do it. Is there anything else I'm going to need from the groups? Well, primitive type, maybe. I don't know. Vertices, got some unknowns. Texture coordinate start index. Are textures used? And then texture number. So we could, you know, probably put that in, but we're not going to deal with that just yet. Oh my. All right, and crash. Okay. So probably what we need to do instead is we just need to take all the vertices and put them into the mesh. Maybe? Yeah, let's take this. P file. No. Vertices count. Int. Because that will match that. P vertices at. And then we don't have the model right now. We could just put literally all the vertices in for every single group. in fact, let's just try that. Because I'm thinking it was more than likely the you know, lack of vertices. Oh. So what'd the log have to say? So it was having problems with this. Do I even need these if I'm adding them directly? I'm going to try no. I mean, they said that you needed to, you know, account for that, but what if I don't? What if I'm only including the polygons I need for that, or the points I need for that? Okay. Still having a problem with index out of range. After creating the model. P-file polygons. Current group. Polygon start plus I. Alright, well, let's do a log here. Current group. Actually, let's just do poly index start. Okay, so now we know what the index start is. So maybe we'll find out if there's a problem here. Polygon index start is... There are not that many polygons in here. Oh wait, is this like a data byte offset? To read this group, you have to read... Oh, you know what? I may not be reading it correctly. Yeah, okay, unsigned lawn. No, I'm reading it near as I can tell correctly. Okay, let's let's try and figure this out. So for this, I'm going to need to make a new definitions file. Okay, so I'm trying to remember how these definitions work. Well, that's what other ones are for. There we go. No. Okay, so struct p header data. We'll just do car data 128. Yeah. All right, unsigned int syntax error. All right, good news. That grabbed all the data. So next up, we write the rest of the data. But we can like copy and paste a lot of it from here. Yeah, I want to be able to... Ah, there we go. All right, let's get rid of that. So number of vertices is 14. Number of normals is 14. Number of vertex colors is 14. Number of edges, 36. Number of polys is 24. Got some the unknowns are nothing. Number of hundreds is 1. Number of groups is 1. And the runtime data, no clue. Okay, so should I have that kind of... I suppose I could. Yeah, we'll do that. All right, so I don't think I can make this bigger. Yeah, I can't scale this up. So I'm using this to just quickly be able to check things out. So okay, so we know that the first vertex is right there on the X, Y's, and Z's, or at least vertex number 1. So let's see. Okay, so now we know that there's unknown is next. Followed by UV coordinates. To F. UV chords. Header. Num. UV chords. Correct? Yep, good. BGRA 8-bit. And this is vertex colors in header vert colors, I believe. Num vertex colors. That's what it was. Let's double check. Oh, nope, I got something wrong. $95. Line unknown 1, not generated since size array is 0. Interesting that they're all the same color. Oh, no, wait, that makes total sense. So the array size for those are 0? Indeed they were. Okay, so up. Let's save that. I'm going to actually move this off over here so it's a little bit easier to read this stuff. Actually, I'll put that on the other screen. Okay, so now int edges in header num edges. I seriously don't know what those are for. I mean, it's just weird that it's in that. But I'm sure that they have a reason for it. Maybe it's so they can highlight them and select them. Alright, so poly polygons. And this is going to be the big guy. Header num polygons. Double check. Oh, we had a fail here. Num polygons, not a member of the structure system. Yep, num polys. Had a feeling. And then I forgot I can't just like copy and paste. I can't duplicate unknown 2. Num unknown 2. Okay, that's good. Unknown P unc 3 unknown 3 header dot num unknown 3 P hundreds header num hundreds. Now, you know, the reason we call it num hundreds or hundreds even is because they didn't specify what the hell it was. They said there's like a whole bunch of data in there about like shaders and stuff, but none of it was documented, and that really kind of pisses me off. Alright, so here's the one I've been looking forward to. P group. Groups. Header.num groups. Alright, with that, and syntax error. Yeah, that would be why. I was like, why isn't it working? What's going on? Oh, I forgot to add some classes. Alright, so let's just finish this off. P bounding box, header dot num bounding box. Is that boxes? Int normal index table equals header dot normal index flag. I think. Oh. Line 28. Num bounding boxes. Num groups. Oh, no, that's all right. Well, you're still having a problem, huh? Oh, bound box. Okay, so now we can actually read the data. So let's come here. Okay. Oh, 4 times num vertices. Okay. Header num vertices. That'll fix that up. And then there's a little bit of extra data. At any rate, we were looking at the polygons. 0. It's 7 for us. So I don't think it is what they think it is. You keep using that word. I don't think it means what you think it means. Okay. Alright, so we're still normaled. Yeah, the normals still look right. We got vertex colors, but I think... just looking at the structure, it looks like we have twice as many as 14. What does the header have to say? Num vertex colors 14. No. Alright, what does this say? Section size is 4 times number of vert colors. Alright, no, that's accurate. So, yeah, that's 4 date. That's 4 times number of vert colors. polygons. Okay, there are polygon colors. Why did I not have those? It would explain why things are a little off. Alright. 4 times... Okay, yeah. Yeah, there we go. Okay, so there actually is a polygon colors. So where is our colors? There they are. There's the vert colors. Num polygons. Polygon colors. There we go. Push back. And this is just going to be head num polys. So that's likely what was causing our problem. So much sign mismatching. So now it might actually work. Well, at least it's back to where we were. Almost looks right. Okay, so we are currently, so we're grabbing the vertices from there. Now, in this particular one, there's only one group. So polygon start index is going to be 0. Number of polygons is 24. Vert start index is 0. So it's just going to do them all. Yeah, number of vertices. Yeah, they all match up. So effectively for this model, what we're doing is still accurate. So the question is, are we reading the data correctly? So we're creating the vertices, we're creating the polygons. You know what? There's an easy way to figure things out. So we have our min and maxes right here. And I should have the same min and maxes over here. Alright, so yeah, we got our mins and our maxes. And those are very different numbers, it looks like, almost. Okay, so our... They may be adding, some more stuff. We're like 100% accurate. We're going by the points. Only one of these numbers is even close to matching up. Well, actually, two of them now I look at them. 3 of them. Okay, so the maximum X is showing up in our maximum Z. Oh, number of edges is 0, so I think edges might actually just be 2-point polys. If so, that's interesting. Okay, so how are we going to fix this? We're displaying the information correctly, or as correctly as we can for right now. I think we have to look at, you know, some information here is getting added incorrectly. So let's see if it's just backwards. So we'll start with Z, and then do X. Who knows? Maybe that'll work. I doubt it. Tired of those. All right, so and as a reminder, this is what it should look like. I don't know if I can turn on, I don't know if there is a wireframe mode. This is such an old file. Old program, I should say. Okay, let's try that. I mean, I could be doing this with just the offsets, but it's a little bit easier this way. It's more fun this way. Okay. Just tired of seeing all of these errors of, oh, you can't do that. It's going to cause data loss. And yeah, you're probably right. I should be doing this with double precision, but, you know. Okay. don't think it's how I'm reading the data. Getting floats, getting ints. Int. Unsigned shorts. While groups is something to worry about, at the same time, I don't think it's giving me the data I need. So maybe I am getting the vert index and normal index wrong here. So let's check the polygons. Alright, so it says that we have, 0, vert index 1, vert index 2, and then vert index 3, and then normal indexes. Alright, well, let's, we have that. But let's open up this guy and see what we have. So, those are the groups. Let's go to the polygons. We'll start with the first one. Short 0, that's fine. 1, 2, and 3. Alright, that just seems a little weird. Normal index of 2, 10, and 5. That's weird. 1, 2, and 3 for the edges. And then the UV index is wrong. It is massively wrong. That's a... Probably because there are no UVs in this. Oh, shit. Is that offsetting everything? Or are those just error numbers? It could be they're just error numbers. Size is 24. Why is this wrong? Except it looks perfect in this. Oh, you know what? That's probably in hex. Column display. There we go. Okay, yeah, it's saying 24. Okay, so let's assume that these are backwards. We'll start with that one first. Well, I bet this is going to cause an even bigger problem. But at this moment, I'm willing to... I'm willing to take that chance. Are you? And I just gotta know if it fixed it. Or if it caused more problems. Oh, yeah, so many more problems. So we'll have to figure out what's going on with the initializing and fix that. Meanwhile, let's see if this worked. Well, looks a little better. Still not... I still feel like we're getting the wrong data. Because no matter how you look at this, it's not looking like it's the right stuff. Yeah. Alright, let's try this. Because that actually worked on one of my other setups. And it might work here. Ooh, what's this? Offset? What's that for? Okay, that's something different. We don't have to worry about that. Although I do want to find, you know, a multi, you know, part model. See if that, you know, how that causes problems. But first things first, let's try and get one model to work. You know, specifically, Cloud's Waste. Alright, no, that did not help either. Alright, well, we tried. Okay. Polygons have group relative indexes to vertices. That means each of these groups start from indexes, yep. Okay, maybe I got something wrong about the vertices. Triple floats. Section is always present in the file. Alright, let's try a different file. We are looking for AABA. Yeah, right there. Go away. Ooh. Alright. Where'd that crash out then? I mean, I don't expect to figure it out where, you know, everything happened. Polygon index start got really fucked up by that. That's because I had multiple polygon indexes. Alright, let's try opening this one in the editor. So, BAA. And this is the one for Cloud's face. So let's see what happened. And run it on Cloud. Unknown 1, 2, and 3 are not generated because of zeros in the header. Num vertices. Okay. Nice part is, by using this literally the same data, you know, we can figure out where things are and then try and fix it. Okay, so polygon 1, vert index, all right, normal index, edge index, UVs, okay, yep, no UVs on that polygon. Yeah, let's go with the groups because that's actually where the data issue was. Number of polygons, 172. Anyway, you look at the data, yeah, that's going to be right. Primitive type 1. Polygon start index, num vertices, okay. Yeah, this one has multiple groups. Polygon index start. Number of polygons. Index start for that. Okay. Group 3. Yeah. Okay, they all had reasonable numbers. So why did, after polygon index start, creating polygons, and then the next one had a major problem? So, able to read that. And then polygon index start got mucked up somehow. Yeah, polygon create index start. So that reported the correct number 1, 2, and then on the third one it crashed. So polygon index start for group 1 was just fine. And then when it should have gone to 172, but instead it goes to 175, which is this one. What? You know what? Instead of doing group count, p file header num groups. Although the count would have been better, more accurate. Alright, let's give this one more shot. Alright, that got added. Good. Okay. And adding... Oh, wrong one. Nope. We're still getting the wrong polygon index start for the current group. So you know what? Maybe if I just put this to in I, since it's an integer. But you would work too, since that's an unsigned integer. Ah. Well, Polygon index start. I'm going to have to dig into this later. Guys, that's going to be it for tonight. Thank you all for joining me. This has been a lot of fun, even though I think I was doing it all by myself, and it's just been frustrating. But the fact that we actually got something to show up, even if it's not perfect, it's still something good. I'll have to dig into this, see what I can do, but I'll try to keep you up to date. That's all for tonight. I will see you Wednesday. Hope you all have a good evening. Good night, everybody.